Hello, Michelle. How are you doing?
Good. How are you?
Good, thank you. Let's see who's here. Smelly. Hello. Okay, so it's 5 o'clock. We have a little bit to do today, so we're gonna go ahead and get started. I posted the asynchronous, concurrency, and reactive programming, or I'm sorry, Asyncio and Rx for lab 7. You can find the document there. So for this particular lab, you can use your IDE. And if you're using your IDE, make sure that you bring in the packages, because if it's not linked with the system variable, then it won't be able to execute. So make sure that if you're using like Tawny, like in my case, make sure that you use tools to add. And if you're using Visual Studio, make sure you bring in the package in Visual Studio. Okay. So to start, we are going to do a few sections, and they're generally pretty fast. And so the first 3, it's going to target async IO or asyncio. Okay. And this one is where we are going to start with comparing the synchronous and asynchronous, very similar to what the book have. So I wanted to expose you to some exercise where you would look at the program and be able to build a program that would provide you the comparison between the two. And then later on, we are going to work on mostly asynchronous and also concurrency. So we are going to implement async IO or asyncio, right? And we are going to look at the order of execution. So that way it's clear to us that concurrency is going to be faster. So now the program is going to include synchronous and asynchronous, the non-deterministic task, because we are implementing some random sleep time that's going to be added to your event that would generate an array of tasks. So here it says that the output will vary based on each task, and because it's going to sleep at random amount of time. And the result is going to be different. So that way we would see that, this what the system would be like. And we're going to build a group of tasks and put that into an array. It does not do non-blocking by itself. So in this particular program, keep in mind that we are not having a non-blocking functionality because we don't implement futures in this particular program. Okay. In the later program, you will see that we would include futures. So one of the function that we're going to use is going to be gather. And I pulled the function information from the documentation. So you're going to see awaitable async IO gather, and this allows us to run awaitable objects. And it's going to be concurrently with the sequence of what you're passing here in the parameter. And awaitable is going to be in whatever the value that you pass here, that's going to be a coroutine. So that's how we're going to be able to implement coroutine in this particular case. And when it's successful, then it's going to aggregate the return value. Okay, so these are just the criteria for this particular function. So to start, you can open your command prompt or you can use your IDE and install. So we can do a pip3 install Asyncio. And on mine, it should say that's already met. So it tells me the path here that it's going to put it under lib, under site packages, and it's for my Python 3.9. Now, when you do that, if you're using an IDE like I do, you still want to make sure that your plugins is managed. So you would go to tools, and then you would search for Async IO and make sure that you install it. Okay. And also notice that because Tawny uses Python 3.7, so it's going to put that into the packages for Tawny with 3.7, as it would be different than if I install it on my command line. So, okay. All right. So let's take a look at our program after we install. So on this one, we're only going to use Async IO. And the program is fairly short. Okay, you're going to import random. That's going to be for your sleep time. And then we are going to implement time from or implement time. So we are going to import in time with sleep. And that's going to pause it and release the resources back to the system. So that way it will be able to do asynchronous. Then we define a function. And in this way, we treat every task as a process. So we would use a PID as a variable there. So the first function is going to be task. And this is going to allow us to implement the random sleep. So since I'm using ranint, I want to be able to use multiple argument there. So it's going to start and stop there. And we're gonna increment, we're gonna apply the multiplication of 0.001. So that way it will seed and be able to give you the random sleep time. Then for the second function, since this is asynchronous, keep in mind that when you define a function for asynchronous, you need to make sure that you put async in front of the definition. So in front of def. And this is going to give us, so the function name is task coro, and this is going to be your coroutine. So in the coroutine, we need to implement awaitable. So that means that we have to write a statement to make sure that it's going to have await. And we are going to use what we used in the random sleep time earlier, but we are going to tie it back and use the property of async IO. Because await comes from async IO, that's what you have to implement. Then we want to print again. So the reason why we want to print is we want to print and track, right, as it call on these functions, how fast it's going to be. Or I'm sorry, how it execute the task in order or not. Okay. So you will see that when it does the synchronous part, which is the following part, starting from line 15, it's going to go from task 1 through the end. When you use asynchronous, you're going to see that as it waits, it's going to release that resource. And so therefore, it's able to execute the task out of order. So again, we are going to have another function here that's going to be synchronous, and we simply implement a for loop to generate our task. So it's going to loop from 1 through 10. Okay. And then for the asynchronous, we are defining another function here. And in that, we're going to have task is going to be, and here is where you would bring in the coroutine. And you are still going to have to implement the for loop, as it has to loop through your list of tasks from 1 through 10, but we are going to add in the coroutine, so it's going to be able to sleep in some part. And earlier we mentioned that we would use gather. So here and the way that we use task here is we're just going to bring in task, pass it as an argument there. So we're gonna implement await, and we're gonna use the gather method. So now we have all the functions, we need to call them. So first we can print, and so we know which is which, and we're gonna call synchronous. Then we're gonna print and call asynchronous. And asynchronous, keep in mind that when you want to execute it, you have to use async IO run. That's the method that you have to implement. So that's different than your synchronous in that you just simply call a function there. In async IO, you have to implement run for asynchronous. So when you run this, let me pull up so you can see. It's giving me the synchronous task. That's expected. We're going to go from 1 through 9. Okay. And then for the asynchronous, when you notice that it's going to go 1, 2, 3, and then it's going to jump to 6, 7, and then back to 4, go to 8, and then 5, and then 9. So we do see various tasks that's going to be out of order. Okay. So here, doing this program, it allows us to examine how coroutines is used and how to implement async IO. And we're also going to implement random sleep time, but we want to show that asynchronous task is going to be executed out of order. Any question? Okay, so coming back to the lab after you put in the program and run it, you are going to provide a screen capture of your code and output. And I want you to explain the role of coroutines in this program. What is it doing? How is it used in asynchronous? And for 5, how is the execution of asynchronous tasks differ from synchronous tasks in this program? Okay, so as it implement, so we use a coroutine. So as we implement the coroutine, what is it doing to be able to pick up the other task? Okay, so make sure that you answer these questions and provide the screen capture for part A. Now, knowing the order of asynchronous that would be differ from synchronous is important, right? But we want to really see the application behind this. And as and as the notes and the chapter talks about how this would be used in networking and web development and so on. And keep in mind that async.io, asynchronous programming is not just for Python. You can use this for JS, you can use it for Java, you can use it for other languages. Concept is the same. In general, you're gonna have a library like this, right? You can implement async.io and be able to use it across different languages. Now, of course, syntax for the others are going to be different, and how it's implemented in the program is going to be different. But the concept of using await is going to be the same. Okay, any question? No question. So the takeaway for this is, how we define the functions for asynchronous compared to synchronous, right? In general, so far we've learned for if you just write a simple program without using asynchronous, that's simply a synchronous program where it's going to go from the first line to the last line. And so if you want to use concurrency, you can consider using asynchronous functions, be able to call it, and then we need to implement coroutines with that. Any questions? Okay. So that would be part A. Not too long of a program. Part B is a little longer, so I copy and paste the code in there, as it would be like about 50 lines or so. So if you already install Async.io, you can skip number 6. And you also need to install aiohttp. So in part B, what we're doing is we're writing a program that implements these libraries to submit GET HTTP requests to the server. So it's going to go and fetch for us, and we're going to put in the domain or the URL. So you can put in any URL of your choice into the program. It's like accessing your browser, and when the browser uses the URL, what it does is it's going to need to go out and it's going to need to be able to get HTTP requests. And here it talks about by using asynchronous call, we can make all the requests for the services at the same time instead of, sequentially wait, going from the first request to the second request to the third request. So what it will do is it's going to queue those requests and it's going to execute them at once. Okay. And each of the requests is going to yield control flow. So that way to the next and then returns when it's complete. If, right, we are doing them sequentially. So you are going to see a few requests, right? 3 that's going to be submitted as a task. And when you're running it in synchronous, you're going to see them that they are varied in time. But we are going to examine the slowest request, the one that has the longest time. And we're going to compare that to asynchronous, where it's going to be able to execute all of them at once. It's going to process all of the requests at once. And that time is going to be compared to the slowest time in synchronous, and you would see the difference. So your synchronous and asynchronous is going to be similar as far as code, as what it says here. And essentially it would be the same, but the main difference is that we implement the library to perform the GET request. Okay. And we would use a single method for creating and retrieving results from the coroutines, which allows us to create a set of tasks and wait while they're finished. So let me get my thing. So for this one, don't forget to also install the library. So aiohttp, you're going to search for, and then you can install that. If you want to do it in command line, I put down the command for you to use. You can use pip. Let me clear my shell. Okay. So like the part A, we are going to have two pieces in the program. One is going to be synchronous and the second is going to be asynchronous. But unlike the first one, this one we are going to implement aiohttp so we can write the GET request. So you would start out with defining the variable URL, what that would be. So you need to put your URL in quotation mark, whichever site that you want to get from. And then you want to set your clients. So like the first one, but in this one, we are gonna first define the fetch sync, which is gonna be for our synchronous side. And we want to print it. So we wanted to look at the time that it starts. Okay. And we want to also be able to look at the response and the response. So in, if you're familiar with networking, I know some of you are in networking classes or took IT classes, right? In the header of your packets, it actually has the information of the response and the request. So what we want to do is we wanted to store the date information from the header to date time. So basically we'll pull the timestamp for that. And using that, we are going to be able to look at, right, the time that it starts and the time that it finished, so we can take the difference. We've seen this before with the other libraries. So we can take time.time method, subtract the start, we would get the difference, and then we would return. So we can see that would be the amount of seconds that it takes to have that GET request. Then using aiohttp, we're going to define another function, and this is an asynchronous. We're going to pass the URL. Now, as it established or it's obtaining the communication with HTTP, we are going to have a session. So here is where we are going to do an async with, and this is the client session. This is built in. It's factory method. That's what they call it for that library. And we are going to put that into session. And then we are going to also return the response after we get this response for that session. And in the asynchronous, ultimately, it is the same as synchronous as you see above, right? With the fetch sync. We are gonna be able to examine the time by using the start time and look at the response, but slightly different in that we are gonna implement await. Okay. So that's the main difference between that and this response for the synchronous. So we then would print out the time. And for the synchronous, we are going to have a for loop. We are going to call on fetch sync, which is the first one that we define. And then we'll be able to have the process time. So here we simply implement a for loop, a for range. Then in the second, another function, we're going to define asynchronous, and similar to the last one, we're going to have a start. But for our task, we have to redefine the task for that, because we have to create the task and then we are going to call on this function here. Okay, as we're going to loop and store that into the task. Okay, then we're going to wait. That's where we would be able to add in the coroutines. And then we're going to print. So when you run this, you would see that let me pull up here. So it's going to give you the synchronous. It's going to go process 1. It's going to give you the time for process 1, that's 61 seconds. Then you have a process 2. So when it finished 1, it's going to go into 2. And that's going to be 30 seconds. And then process 3, after it finished process 2, it gives me 30 seconds. So the total for all 3 process, because I can't load the web page until all of those processes are complete. So it's 1.21 seconds. Okay. And we want to measure this against asynchronous slowest, because in asynchronous, all of these processes are processed at once. So when you look at the bottom, and we purposely printed it out, so it's going to start 1, 2, and 3, because we had also implement the coroutine there. So at that point, it's going to wait to make sure that all of them are already set up. Then it's going to execute them. Okay, so it's processed. It's going to be 48 seconds, 46 seconds, and 46 seconds as we are in the scale for 46-ish, right? So we can estimate it, we round it off to about 49 seconds. Okay, So compare that to something that is sequential in synchronous, you would see that you do shave off some time there when you implement asynchronous. So when you're designing a web app and you are gonna use, right, that you have to tie it to the domain that's hosting the content of your web app, right? Consider using Async.io and be able to implement asynchronous processes for connecting to that particular site. Now we can use this with database, with, with web, with other servers, and so on. So, and this is just one example. You will be able to find additional example if you spend a little bit of time reading some of the tutorials and things like that. You'll be able to find more. But the takeaway from this is if you are able to write this, right? You see that we started with two type of functions. The first is going to be for your regular fetch sync, and we are going to do an HTTP GET with an asynchronous. Then we have to add the asynchronous fetch sync. And then for the last two function, we're going to use those functions to call the others accordingly. So the asynchronous would call on the asynchronous fetch sync. And then for the synchronous, I'll just use the regular fetch sync there with the for loop. Any question? And similar to A, you see that we would implement await, but in this one, we added a second library. So earlier, in part A, it mentions that Async.io doesn't have it's non-blocking by itself. It doesn't do that. So you have to implement it with other libraries to be able to effectively use asynchronous. Okay. And that could change as they modify the library over time, of course, but right as it is now. Any question? Okay, so put the program in, run the program. Why did async process take longer? If you add up, okay, so when you evaluate the time, okay, so the synchronous on mine is 1.21 seconds, and the asynchronous is 0.49 seconds, which is the longest process for the asynchronous. Asynchronous doesn't it start everything and then it's going to process all three together, so you don't total them up. Okay, the synchronous, you total them up because it has to finish the first, then it goes to the second, then it goes to the third. But with the asynchronous, it loads, it fetch all three, and then in the 49-second span, it's going to execute all of them concurrently. Okay, so you don't total up the time for asynchronous. And I hope that's clear. So think of it like if you have, multi-core, it's going to execute all three at once for the asynchronous because it's able to release the resources. So it's going to do them all together. Yeah, individually, yes, because you implemented the time wait. You implemented the await. So if you're looking at them individually, they are longer because you have that wait time inside the coroutines. Okay. right here. So 48.48 is for the process one is the process of both async wise. Yes. So it's actually a little bit higher than 48. So it gives you the round up, which is 0.49. We evaluate the slowest process in the asynchronous, which is that process one. Process one took the longest. Now, if we compare that to the total for the synchronous, it's half of the, it's less, it's like what, about a third of the total of the synchronous. But if you compare that to the slowest process, which is also process one, right? You see that it is slower than the individual process in synchronous for sure. But in synchronous, in order to really have that session, you have to have all three of them done, right? One after the other. Now in the asynchronous, you can achieve all three in the 49 seconds. You're welcome. Other questions? So doing this, you're gonna find it's really interesting how we don't really look at the back on what is being implemented and how you can really, improve. But if you're testing applications or if you're looking at like how the application's designed, you can take a look closer on, if you're striving for performance, you can take a look at closer on whether it's going to be synchronous or asynchronous. And in web development, this is very common. Like you would see asynchronous and reactive programming heavily used. Okay. And then we'll touch on RX in a little bit. So my whole purpose in this is the first exercise kind of warm you up and show you the, how you would build out that code to really have synchronous and asynchronous. Okay. And then on this one, you can see the application behind it because no point in learning it if you can't really use it in the real world, right? So we wanted to examine on how it would be implemented for web purposes. And then for the next one, the next one is where we would elevate it a little bit and we would implement features. So in the third part, part C, it talks about concurrency and, that's mainly our chapter. But it starts with talking about coroutines. So coroutines can be scheduled to run and retrieve the results in different ways. If we need to process the result of the HTTP GET request as soon as they arrive, so we wanted to be able to process it as soon as we get it. So what we can do is we can implement the timing of the result call as they are scheduled at the same time. So as they are arriving out of order, we can process them as soon as they arrive. Now, this is different than the last one in that we are pulling all the coroutines into a list. And each of them is to be scheduled as they arrive. So the as completed functions returns an iterator. Okay, and remember we talked about how concurrency, we will implement the iterator generator to give you yield. So we are going to yield a complete future as they come. So future is just a location where we would create and we would reserve that for as they come, right? It gets loaded in there and it's going to get scheduled to be executed. And so we would use as complete, which is from the actual concurrent futures module. Okay. So that kind of stage on what you will be doing, compare this program to the last one we are going to add in futures. Let's see. So we're using the same library. We're using aiohttp and asyncio. So you already have those installed for the prior two. The beginning of the program is very close to part B. So you have the whatever URL that you're trying to use, and then your max client is going to be 3. And we are going to define an asynchronous function. Okay. And it's going to do the, it's going to do the HTTP GET. And just like the last one, so the first part of this is the same. You're going to have the session from the response. Then in the second function, we are also going to have an asynchronous function. And we're going to have a start is going to be our time. So we are going to pull the time stamp there. And our sleep time is going to be random. Then we have an await asyncio sleep, and we're going to pass sleep time. And then we have the response. We are going to implement awaitables. Okay, for the get HTTP. And just like the last one, we're going to get the date for the header, and we're going to put that into date time. We're going to end the response. So for this, we are going to return, right, the time that it's going to take, the difference in that. Now, this is another, it's a different function here. So here we are going to define a main. That's going to be asynchronous. We have a start. Then we define futures. And as it needs to iterate, it's an iterator. Okay. So here we are going to call fetch sync function. And then we're going to have a for range. And there's another for loop that's nested to enumerate through, right? Because remember that the task is going to come and you want to take that task and store it into a container, which is a list. And you would pull that task, right? And then be able to execute it as it's arrived. But it has to be scheduled to be executed, because there's a, that's how we're going to be able to implement the coroutine. So we put it into the futures, and as we store that there, it's going to be able to go there and be able to execute. So our result is going to come from future. Okay. And then we're just going to print all the subsequent. And then we want to print out the time, which is in seconds. So as you subtract that, you would have that. So then at the end, you just call on this function with asyncio run. So this allows us to execute an asynchronous function, which is main. Okay. And keep in mind that we are implementing random, so it would look different each time that you run it. And mine is going to be different than yours. there's other factor that we have to include, like connections, hardware, processor, etc. Okay, so we have 3 fetches, right? It starts and it's gonna sleep. So the first one sleep for 4, the second for 5, and the third for 2 seconds. And then it's gonna do the process 2 first because that arrived first. Because remember, it's 2 seconds. And then it's gonna go to the first, as you see, that will be 4 seconds. So it's gonna execute that, process 1. And then it's gonna execute process 3. That's the slowest, 5.2 seconds. Okay, that one sleep the longest, so that one takes the longest time to complete. So when we measure this, we take a look at the longest or the slowest process, which is process 3, and that's approximately 5.28 seconds on my system. Questions? So futures is used to track awaitables, right? And the status. So as it comes, it's going to be able to know. And if it waits, it will be able to know. So it's just a location where it stores all the updates for each of these as they started and sleep. So when you get HTTP, does the program wait for it to open? Yes. So depending on how, so when you use browser does get HTTP. And if it is synchronous, then it will just complete the 3. But if it's asynchronous, it does wait because it would allow the other processes to take over and execute. The way that we get, there are what you're gonna do multiple, you're gonna do 3 gets, right? And it has to reply 3 times. So if we sequentially wait for that, it would take a while to open up the app to be able to get the page loaded. Because HTTP uses TCP, and the way that it sets it up is that it needs to be able to validate that the session is taking place, and that's how it's going to serve the content, which is the index file. So your request doesn't necessarily have to arrive one at a time sequentially. That's what I'm saying. So in this case, when we're implementing asynchronous, you do see that processes, right, the requests are arriving out of order. Because even if they're arriving out of order in the synchronous approach, what will happen is it's got to wait for the 1, 2, and 3. If the first one never arrived, it gets stuck there and it takes a long time to even load that, right? So if we use the asynchronous approach, what will happen is whether it arrives first or second or third, whichever order it's going to be, it's going to run that. It's going to be able to put that into the wait, sleep, and then be able to execute it. Now the future, the way that they implement this is we want to store it, right, in a location, and it's going to be able to check the status of that. And so as it arrives, we want to be able to run it no matter what order it's in. Now 5.27 seconds, I feel like it's still long, but so the response and the return response is an HT, yes. Yeah, because when you get the response, you also get, you know, the timestamp and the response. Although that means that it's actually completed, it fulfilled that request, that fetch. Other question? So you want to print, okay, right here. Yeah, so you do have some session. I think that it's gonna tag it as a status. Yep, you can print out some session information, but I think you're gonna get packet information anyway. It probably won't be because so then you have to take a look at how this method is written, because this is how it's acquiring it, is to use the client session, right? So I think that it has some header information and it has some data information, but I'm not specifically sure on this method and how it's incorporated to print. That is right. Yeah, if it stores it, maybe you can check and see what's inside the content. So in the book, it gives you the network monitoring tool, right? Or the CPU, actually, the CPU monitoring tool. You see a lot of those type of applications using asynchronous. So if you're writing like a monitoring applications or something like that, this will be useful information. This is the type of library that you use. Other questions? I was gonna add another section for reactive programming, but I felt like 4 things are already. I want to give you time to kind of digest some of this and then, examine it. But there are a lot of great resources online and other type of example if you wanted to use it. Okay. So if you look at ReactiveX, ReactiveX supports, right, different languages here. And as you can see, these are used for web, right? Swift, that's for iOS, Clojure, Scala, Net. This is for Microsoft, JS. That's Node.js, and then Java. You can find some documentations. So basically, reactive programming, you are going to have the same elements across all languages. You are going to have observable, operators, single, subject, and scheduler. So this is used to stream data, stuff that you use like social media, videos. And if you go down and if you take a look at who uses ReactiveX, these are some of the main companies that use them, right? Like Netflix, GitHub. And then if you are looking at, other social media or other websites, you would see that they also use that for their web app purposes. So these are just some of the examples. Now with ReactiveX, you can tie that in as an API, okay? And to implement your framework for different type of programming languages. Okay. So these, they put this is because there are three main steps. You are going to create, you are going to query, and you're going to listen for data. That's what the system does, right? So before you can stream your data, you really have to build it, right? Like the content. And then you are going to use the operator to make it like it's query like. And then it's going to subscribe and listen. This is where it's going to be, it's going to be running. So here, I just want to take whatever that was in the lesson and review it a little bit here. So RxPy is a library that allows you to use asynchronous programming for events. And it's use observable collections and operators for query in Python. Okay. Now it works with reactive programming because you have asynchronous data call, you have callbacks, and you have event-based program. And event-based program, think of it like when the user tweets something, it streams. And in that case, at that time, you know, it needs to stream the data. Okay. So it's reacting to the event that occurs. So now to handle asynchronous data stream, we would need to implement observables, which query the data stream using the operator like filter, sum, concat, map, and so on. And to make use of concurrency, it needs to factor in the scheduler, which we see in asynchronous programming as we talked about coroutine and awaitables, right? So observable, when you create it, it would construct object with using on next or on error or on complete methods. Now, to give you the overall, so here you have observable, then you have operator, then you have the observer. When it needs to build, it's going to be subscribe, use observer, and then it's going to use this method, these methods. So I redefine these here so you know what they are as you look at that diagram. Observables are functions that create observer. And it attaches to the source of having data stream, such as tweets, computer-related events. The observer is an object with the methods like on next, error, and on complete. These will get called when there's interaction with the observer. So that would be incoming tweets. The subscriber, it executes the observer. And the operator is function that takes the observer as input and output, but it's also known as another observer. So you can use different type of operators or group of operators on observable data using a pipe. And the subject is observable sequence. This can multicast. That means that it can talk to many observers that are subscribed. It can be cold or hot, and the book talks about that. So the subject is cold observable in the case where the values will be shared between the observers. Okay. And then the scheduler is what drives concurrency. It allowed the task to be parallel executed. And so you would use subscribe on and observe on that work with scheduler to decide the execution of the subscribe task. Okay. So those give you the definition for these. So in the below program, I try to make it where it's, somewhat mimicking the real world. So let's say that we make a stock trading system where we buy and sell stock depending on the price. And we want to make an observable object that emits events based on the value of the stock. So we have a function which is going to be buy stock events, and it's going to pass the observer and the scheduler. It's going to iterate through the stock array and call an onNext function. And whenever the price is higher than 100, it's going to do that. So we have to subscribe the observer object, and we are going to use onComplete, okay, and onError. So onComplete is called when the observer has nothing else to give, and onError, which is called when there's an error that's emitted. So you can use these to be able to track if there's error or when it's done. Okay, so in this one, you have to install Rx. Now I want to point out that there is RxPy and there is Rx. Okay, so if you use Reactive, you can simply use Rx. So in here, if you're using IDE, you can just look for Rx. And if you look at the summary, it tells you that this is a reactive extensions for Python. Now, if I look for RxPy, right, this is a regular expression for Python. Remember that for the reactive for Python is RxPy. So if you mix them up, this RxPy is regular expression. And if you use Rx, it's actually the reactive extension, which is what we need. Okay, so therefore, when you run your command line, you would do a Pip3 Install Rx. Okay, so you are going to get that package and install that, or you can put it in, do the installation through your IDE. D. So similar to the book, you would see, so here what I have is I have, right, strings and I have values. So this is representing what? A list that contains dictionary. Okay. So then you have a function. We talked about buy stock events function. We are going to pass the observer and the scheduler. And we have to implement a for loop because this is a container that has elements, or a nested container, right? So we want to implement the condition that if the stock is higher than $100, we are going to stream through these, starting with ticker, and we are going to move to next, and then so on. So it's going to read this and it's going to check against 100. And then we have an elif if it's the price is less than or equal to 0, right? We're going to use the onError, okay? And then we are going to use the onComplete. So we're going to call this function through the create method, and that's going to, so we have an object called source, and that object is, it contains what's created from the function. Okay. Now, your observer won't be effective until you subscribe. You have to subscribe it to make it executable. So here we would have on next, and we put lambdas because remember, if you don't want to name that function, you just put lambda here, and then the value you would then print. On complete, which is one of the three methods you have: on next, on complete, and on air. Those are just they're the same throughout all of these reactive programming type of code, right? You put lambda and other functions, and then we would do a complete tray. And then on air, we just then print E. Okay, let me clear this. So when you run this, right, then you would see that we would receive the instruction to buy Apple. Why? Because it's $100 or more, right? And then another stock is 120. That will be TSLA. And then another one would be Microsoft, 150. And the one that has $0, you know, so investor take a loss on that, that will be your ELT. And that's going to print at the end. That's your error. And if you want to time this, you can also add in the time element. But I wanted to show you that you can use this for this type of application. Let's say that we wanted to make a stock trading program. So instead of like predefine this inside the code itself, you can probably pull, right, live exchange values from a server, okay, have it go and fetch it from the server, store it into a container, right, and then use the same method to check for a certain price, and then be able to set up the instructions to buy. Now, this is only partially. If we want to extend further, you know, you can, what is going to be the instruction to buy. So once it execute this, we can have it contact another server and submit some kind of transaction, right? So if you really want to automate that, that will be the process. And that's usually back-end development. Question. This is event-based. Yes, but it uses element of asynchronous to read data and stream data. Yeah, reactive is event-based. But what you see is you have elements that will be asynchronous. And the scheduler and so on. Yes. So what would be the observer, the object? Yeah, so for what you created here, your stocks. So what it's doing is it has to go and read all of these. Okay. And then it's going to take the content and then it's going to put it into a location, and it's going to need to be able to do something with that. Right. In our case, we are going to be able to take whatever that's in the stocks, right? Make a decision based on that. So bring that in and then be able to execute the task as it's scheduled. So recall here, right? Your observer is just an object that uses on next, on error, and on complete methods. So it takes, when it happens here, this is going to be your observer section right here. Question? So if you look at something like, like Twitter, for example, you have a user that logs in and then that user would then tweet, right? For example, that data, that message is then stored. So that's an event that's driven. So it needs to go in and it needs to pull the data for stream. If I only have one stock, would I need to use RxPY if I'm using an API for stock quote? No, yeah, then you don't need to have an RxPY. You don't need to have reactive at that point. Let's say that okay, so if you decide whether you want to purchase or not purchase that stock, and if you only have one stock, no, you don't have to have that. But the way that we want this is we want, in the case of an event, right? Like let's say that these stocks prices, they're not static. What if they're changing all the time, right? Based on the market value. Today it's different than, yesterday or a few hours ago, but not. Okay. Then what we see is that as it updates this, you want it to be able to read and then to make a decision at that point. Okay. That, because normally we would not have to hard code it like that. I run in just restart. Close out with. Okay. So are you able to, I don't understand. Okay, so it says restart user and close this out. Yeah, so that all depends too. Okay. So you should check where your library is, and here if it's installed, right? If I put this again, it will tell me where it is. Now, if it's not with your idle, then that means that your environment variable for your idle is not set up properly, or your Python, or you have multiple versions of Python. So you have to uninstall them and then reinstall one, because what happened is if you have version 3.5, 3.7, and 3.9, it's going to put it into various locations. And if your idle doesn't see the packages, it's not able to execute it. So But usually you should get an error though. I don't know why it's only showing you like, that means that it ran. It doesn't print out something for you there. If it doesn't show error, it ran, but it's failing to print. It shouldn't. We have print functions stated here. What you can do, Alex, is you can do this, Python 3, and then call your file name and see if it runs it that way. If it's throwing an error, just that means that your Python's not linked. Questions? Okay. Let me see if it works this way for L. Let's see, L7 part D. Oh, I have to put in, let's see, CD desktop, Python 3, and 7. Oh. Let me check my file path, see if I can do that. I type in CIS correctly here. And then CD unit 7. Yeah, so if you're getting an error like mine, that just means that it's not able to pull the library. So you can try it this way, go to where your file is, and then see if you can run it. So all I have to do is I need to make sure that my my library is installed, or I set up my environment variable path. I do have like 2 versions of Python on here. I have 3.7, which uses Photoni, and then I have a 3.9, which uses idle. So that's why it's doing that. So some of you have that issues because you have 2 or more versions of Python. And to get rid of that completely is to uninstall all the versions and use one. Or you have to just manually, set up, because your system environment variable is only going to be tied to one version. And so whenever that you execute Python 3 command, it would only use that one version that you had set up in environment variable. But if you have 2 things set up, it's going to get confused and it's not going to work. So I think, Alex, you can set it up to see if it can run through command line or idle. If idle doesn't show, if it fails, I don't know why it's doing that. So maybe let me see. You have to check your error. Yeah, sure. Mhm. Let me copy your error. Okay, I'm gonna stop recording.